Assalamu alaikum. So this is an PIR sensor and Arduino project. So what PIR sensor actually does, let's see. So if let's say between the range and object, this is an object, and if this object starts moving, this PIR sensor can detect the movement and then send the signal to the Arduino, and this Arduino will operate this buzzer and as well as this LED. Well, let's do the same thing again. So how to make this thing? So in this video I will use TinkerCad, but you can use this practical with practical component, but I will in this video use this TinkerCad website. And to do this, let's first go to the TinkerCad, and if you are new to the TinkerCad you have to create an account, but that's not the problem, it's easy. And then create circuits. Okay, so now search here breadboard or Arduino. So this is one Arduino here, but inside starters you can see that I have an Arduino with breadboard. So you can see that the positive 5 volt or 5 volt is connected to the positive rail of the positive power rail of the breadboard, and it is also connected here. So let me take this thing. Okay, so then I will need a PIR sensor. So let's take one PIR sensor and connect it here. Okay, so let's connect it here, and then we have to power up this PIR sensor. So let's take this power pin. Let's take this power pin and connect it with the power rail, and let's connect this ground pin here. Let's set the color. This color is, let's say, red, and this color is black. This color is black. Okay, so now we have to write the code. So let's go to the code, blocks, text, continue. Let's remove this thing. Okay, so let's say this is the signal pin of the PIR sensor, and we will take the signal. Okay, so we will take the signal from A0 pin. So let's connect this A0 pin. What's happening? Okay, so let's take this A0 pin and connect it with the signal pin. Okay, so let's draw this color, let's say yellow, and now let's go to the code. So integer PIR is actually A0 pin, and the pin mode, we should take the pin mode PIR pin in input mode, as we are taking input from the PIR sensor, and we will see the input in the serial monitor. The serial monitor is here, we will see that value here. So we have to initiate one serial monitor. So serial dot begin, baud rate is 9600 beats per second. Okay, so then let's declare one variable, name is data. Okay, and inside void loop, let's analog read from the A0 pin and store it in the data. And if we want to print this value, so serial dot println then data. Okay, so I hope this code will work. Simple code. So let me run this simulation, and you see this value is 0. That means this PIR sensor is giving me 0 value. But let's say if one object starts moving, so now it's giving a high value and it will remain high for a certain period, and then it will again becomes low. You see, again becomes low. Well, let me introduce a delay here. Let's say 100 millisecond delay. That's not a big deal. Okay, so now we have to put one buzzer. So if you see someone is moving, the buzzer will be give you sound. So now let's go to the buzzer. So this is actually passive buzzer, this is not the active buzzer, so you have to supply a PWM pin here, and that's why you have to connect one PWM pin, let's say 6. So let's connect 6 with the buzzer, and let's connect this negative pin with the negative rail. So this should be, let's say, orange, and this is black. Okay, and we should use another LED. So let's take one LED and then one resistor. Oops, let's take one resistor. Oh, sorry, let's make it horizontal. Let's make it horizontal also. And to flip this thing, you see this is anode and this is cathode. So to flip this thing, let's click here, mirror. Okay, so now let's connect it here. Where should I connect it? Okay, let me connect one resistor here. Let me connect it with the same pin, this 6 pin, or I should connect it if I do this thing practically. So I have to connect this thing like this. Okay, now this thing will be connected to the negative pin. Okay, so let me take this LED some other color, let's say this is yellow. Okay, so now the main thing is the code. So you see this 6th number pin is connected to the buzzer and also to the LED. That means when I will get the signal, this 6th pin will be on and it will operate buzzer as well as this LED. So my output pin, so integer out, is actually 6th number pin. So this should be this pin mode should be in output mode. Okay, so let's focus on the buzzer. So as it is buzzer, so let's see if data is not 0, greater than, let's say, 500. Okay, so if data is greater than 500, that means higher value, then that out pin, let's analog, oh sorry, well, let me do another thing. You know that as I have mentioned that this is one passive buzzer, not active buzzer, so we have to apply a certain frequency here. So if you put here analog write, you can write here analog write or anything, but I want a certain frequency. So to supply a certain frequency PWM signal here, we will use the built-in function tone. So this output pin will supply 200 Hertz sound PWM signal to the buzzer, and this buzzer this buzzer's inside piezoelectric component will be vibrated in 200 Hertz. Okay, so if this data is high, that means the object is detected, then this buzzer will give you sound in 200 Hertz. and if data is less than 500, or you can use else here, whatever, then you have to make this buzzer off. That means you have to apply another function noton, and you will off that out pin. Okay, that means when an object is detected, data will be high, and this buzzer will be giving you sound in 200 Hz, and after some time this buzzer will give you 0 output, then data will be low, less than 500, and noton function will stop this 6 number pin to give the PWM signal here. Okay, so let me start the simulation and let's see what happens. So I have a problem here. Let's find out. The problem is noton. Problem is noton. Noton T is in capital. Okay, so let me start the simulation again, and I think so this works. Okay, so let me move one object. So you see that this buzzer gives you sound and LED is glowing again. Okay, so if I increase the frequency, you will see that the sound will change. So let's stop the simulation and then increase the frequency, then the stone will be shows narrow, you will see. Now something different sound, right? If it's 500, let's see what happens. You see this buzzer is glowing and also this LED was glowing. Okay, so thus you can make a PIR sensor project. So it's basically students, high school or college level students make this project to demonstrate one thief catching or detecting a thief at night project. Well, that's good one, and we also can use it in another purpose also. That's up to you. You will find problems and you have to use this thing, and comment me that where you can use this PIR sensor, how you can use this thing. Well, so thank you.